Okay, we're continuing on 3.3 and we're talking about the factor theorem. Let f of x be a polynomial. If f of c equals 0, then x minus c is the factor of f of x. If x minus c is the factor of f of x, then f of c equals 0. Let's look at example 6 using the factor theorem. And before I get started, the publisher made a mistake, so depending on when you take this class, the mistake might be fixed by then. I'm going to go ahead and fix it in my video. And they forgot to, or they miscopied this to here. Again, it's corrected my notes and so on. So it should be a minus sign right here. They put a plus sign there for some reason. Okay, so now we know we have, we're going to solve this equation, and we know 3 is the 0 of that function. So we know if 3 is the 0 of the function, we know that x minus 3 must have been one of the factors when you use the zero product rule. We're trying to figure out what the other factor is. Okay, so knowing that, we now know that we have x minus 3, and we're trying to figure out what this is. Okay, when we're using direct division, I know that c equals 3. So I have 2, negative 3, negative 11, and 6. Drop down the 2. We're looking at arrow there. Okay, so I get 6, and then add these together, and I get 3. 3 times 3 is 9. Add these together, I get negative 2. 3 times negative 2 is negative 6, and I get 0. That's good to have 0 there. That means up here, I have 2x squared plus 3x minus 2. What that really means is if I go to my original problem here, 2x cubed minus 3x squared minus 11x plus 6 equals 0. If we have that, we're trying to solve that equation, we know one of the factors is x minus 3. The other factor is 2x squared plus 3x minus 2 equals 0. We're trying to solve this equation. We know one of the zeros is 3, but I got to factor this more to find the other zeros. So we got to factor this. Remember, we can factor this by the AC method. So up here, I'm going to go ahead and do that up here on the side, or up to the side. I have negative 4, and I have 3. So 1 times 4, and I need 1 to be negative. That gives me 2x squared minus 1x plus 4x plus minus 2 equals 0. And I'm going to do grouping here. So I get x, I get 2x minus 1. Pull out 2 here, I get 2x minus 1. So 2x minus 1 and x plus 2. So down here, this is the same thing as x minus 3, and I factor this out, I get 2x minus 1 and x plus 2 equals 0. That means I have my zeros. I know this one's going to give me x equals 3, and when I solve this, x equals 1/2. And x equals negative 2. So those are all my zeros. So in my math lab, they'll ask you for all the values of 3, 1/2, and negative 2. Okay. If you really think about this carefully, this is all the solutions, all these values that can fit in here that would make this equation equal to 0. Okay, on your own, go ahead and try this next problem, and same procedure there, and then when you stop the video, try it, and then replay the video to check your answers. Okay, so I went ahead and solved the equation. I knew that if negative 1 was a 0, then x plus 1 must have been a factor. It must have come from x plus 1. So I went ahead and did that division using negative 1 as my c, and I got this here, and it gave me my other factor here. Synthetic division is so nice because if I tried to factor this by grouping, this would have never worked. I do 4 terms, and the grouping process would never work. And I said that early on we talked about factoring by grouping. That works about 99% of the time, but factoring by grouping would not work here, so synthetic division helps me factor this. So I pulled out the x plus 1 as one of my factors, and this was my other factor that came from here. Once I got to this factor and this factor I'm going to go ahead and try to factor using the AC method, and I did. I didn't show that work there, but when I used the AC method, it gave me these two factors. So I have 1, 2, 3 factors equal to 0, and I get 3 solutions, and there they are right there. Again, I expect 3 solutions because it's a third degree equation. Okay, that's the end of this section. We're going to do more of this in the next section. So in 3.4, we're going to do find more zeros, upon a function. Then we're going to take it one step further and then look at our graphs later on. Okay, any questions, let me know.